Bismillahirrahmanirrahim. So, Corona effect. We have studied that Corona is actually the electrical loss which appears in the form of uh, the sound, the heat, the production of the ozone gas. Okay, actually, the electrical energy of the transmission line is has been lost in the form of has been lost and appears in the form of sound energy. Okay, the light energy means the violet fluid which can be seen around the conductor due to the electrical loss. Production of the ozone gas. This is actually the chemical energy. Okay, the chemical energy and the radio interference is also the effect of the corona effect. Radio interference of the radio and the television, etc. Okay, so now if you want to find out these power loss due to corona, PC power loss due to corona, so we have this formula for the power loss due to the corona. So okay, there is a power loss due to the formation of the corona that affects the transmission efficiency. Okay, it reduces the transmission efficiency. Because of these, the losses in this form appears in this form. Okay, its effect its effect on regulation, however, is less. This power loss is affected by the atmospheric and line conditions too. Okay, the stormy condition or the snow. Okay, so in the foul weather condition, the chances of the corona and the power loss is high as compared to the fair weather condition. Okay, the line conditions means the surface, the spacing between the conductors, etc. Okay, the power loss due to the corona under fair weather condition is given by this 244 over sigma into F plus 25 R over D V phase minus V D naught whole square plus into 10 raised power minus 5 kilowatt per kilometer per phase. Okay, so now what is sigma? Sigma is the uh, atmospheric condition factor. Okay, F is the frequency, R is the radius of the conductor, D is the spacing between the two consecutive conductors. If we have three conductors, so we will use the geometric means formula D12 into D23 into D31. Okay, cube root. Okay, V phase the phase value, not the line value. If the line value is given, we have to convert it into the phase value by dividing it in the okay. So the line value VL is equal to VP over under root 3. Okay, okay, by this way. And VD naught is the audible, the critical disruptor voltage for the audible corona. Okay, and this is for these values will be in kilowatt per kilometer, means for 1 kilometer. If so, if we have a transmission line of the 100 kilometer, so we have to, and if you want to find out the power loss for throughout the 100 kilometer transmission line, so we have to multiply this p with 100. Okay, because this value is for 1 kilometer, so for the 100 kilometer we have to multiply this value with the 100. Okay, and this is for the single phase per phase. So if you want to find it for the three phase, so we have to multiply it with the 3, so that it will be converted to the three phase. Okay, so move on to the next slide, in which we have to perform a numerical based on the previous formula. A three phase to 20 kV, this is the line value. Okay, 50 hertz frequency is given for the transmission line, has a equilateral triangular spacing. This is the fashion for arrangement of the transmission line, which is in the triangular equilateral triangular fashion, each of 2 meter side. So we have to convert it into the meter, centimeter to 100 centimeter. The conductor diameter is 3, and we need the radius value, so we have to divide it with the 2, so we will get 1.5 centimeter radius. The air density factor and the irregularity factor is 0.95 and 0.83. This is the sigma value, this is the m value. Okay, find the disruptive decretive voltage in the corona loss per kilometer, means for the single kilometer, for 1 kilometer. Okay, assume any data if required. If any data is missing, you can assume it from yourself. Okay, so line value, okay, line to line value 220, but we need phase value. Okay, so we have to convert it into the phase value by by dividing it by under root 3. Okay, the frequency, this d is the spacing, radius 3 over 2 1.5, m naught sigma, and g naught in rms is 21.2 kV per centimeter. Okay, so the V naught critical disruptive critical voltage for the audible corona is equal to G naught. G naught is 21.2, M naught 0.83, sigma 0.95, R 1.5, ln natural log, D spacing 200 or radius 1.5. Okay. This is the kV. Now the corona loss PC, power loss due to the corona, is equal to 244 F frequency 50 plus 25 over sigma 0.95 given R 1.5 D. This is actually the capital D. Okay, capital D means spacing. Okay, now this is the phase value. Okay, we have converted 220 into phase value by dividing it by under root 3. So 220 over under root 3 is equal to 127 minus the audible corona. Okay, we have already defined for here. So 122.68 whole square into 10 raised to the power minus 5. Okay, and this is in the kilometer and 3 phase. So if you want to find the value for the 3 phase, so we have to multiply it with 3 3 into this, so we will get 0.931 kilowatt per kilometer. This is the power loss. Okay, power loss in kilowatt for single for 1 kilometer transmission line. Okay, so if we have the 100 if the length of the transmission line is 100 or 50, so we have to multiply it for with the corona total corona loss value, so that we will get the power loss for the whole transmission line. So that was all about the power loss due to the corona. So thank you, I hope you will understand it.